Good morning, America, or Math 1, or whoever's listening. I mean, this is on YouTube, so this could be any of my 157 followers or subscribers. And if it is one of you, I love you and I appreciate the subscribe. If you aren't one of my subscribers, you should like and subscribe right now, and you'll get good luck for the rest of your life. I don't know. Let's go with that. Today, we're going to do word problems. I know you probably hate my intros. I hate my intros too, so just know that I feel bad about them. We're going to skip straight into word problems. We're just going to get at it. So the first type of word problem we're going to do today is a motion problem. It's anything to do with distances and speeds and times, okay? So we're going to see a couple different ones. The first one is Mario drove from Edmonton to Grand Prairie and back, a distance of about 360 kilometers each way. Mario's average speed was 30 kilometers greater on his return trip than on his trip out. His total driving time was 10 hours. Determine Mario's average speed on each leg of his journey. Okay. For all these motion problems, you are going to rely on a very important formula. And that formula will not be given to you, and it's one that you have to be able to understand a little bit logically. So that formula is that time equals your distance divided by your speed. I'm just going to say speed. I should say velocity, I'm pretty sure, but I'm just going to go with speed, which is a formula that kind of makes sense, right? If I have to go to Calgary and it's 200 kilometers away and I'm driving 100 kilometers an hour, it would take me 2 hours, right? Because 200 kilometers divided by 100 kilometers an hour gives me 2 hours. So we need to use that formula in all of these motion problems. Anytime something's moving, whether it's a car driving, a boat driving, somebody running, anytime there's motion, we need to use that formula. We also need to find at some point when they reference time in the formula. So when you read this question, it said his total driving time was 10 hours. That means if you took his time there plus his time back, it would equal 10 hours. They always reference time somewhere in the question. Sometimes they say it's the same amount of time. Sometimes they say it's 2 hours faster. They always reference time somewhere, and then you have to try to create an equation from that. My equation is that my time there to Grand Prairie and my time back should total 10 hours. Then I need to turn these into formulas using this. So I need to change time there into a formula using distance and speed. So my time there should have taken a distance of 360 kilometers divided by my speed there. My speed there, they never actually tell me. They told me Mario's average speed was 30 kilometers greater on his return trip than on his trip out. But they never said what my speed was. In fact, they asked me to find speed. It says determine Mario's average speed. Determine his average speed. So that means speed is what I'm looking for. So when I'm trying to create my formula of d divided by s, distance divided by speed, x is my speed because I don't know it. So my time there is equal to my distance there divided by my speed there. Plus, now I want to try to turn time back into distance and speed. The time it took me to get back would be the distance back, which is 360, right? Because I drove back the same way. Divided by, and this time it's not x, because the question said it was 30 kilometers greater on his return trip. So on my way back, it was x plus 30 kilometers because I was going 30 kilometers an hour faster. And of course, it still equals 10. The setup is always going to be the hard part for these word problems. If you can set them up, solving them is usually not too crazy. This is one of the harder solving ones, but for the most part, the solving is not bad, as long as you can do the setup. So a review of the setup. I recognized it was a motion problem. Motion problems involve time. It told me that the time there plus the time back would be 10 hours. So that was where I started my calculation. Then I remembered my formula that time is equal to distance divided by speed, and I changed those things to be distances and speeds so I could actually create an equation that would find my speed. To solve this thing, you have to have a common denominator. So this x plus 30 is in brackets. That means I have to multiply this one by x plus 30. And I have to multiply this x plus 30 by the 10. Right? Because remember, that is now 10 divided by 1. So a common denominator has to happen to all things. This x also has to multiply to all things. So it has to multiply to that fraction and to this fraction. We now have a common denominator, which means we can cross out our denominators, leaving me with 360 times x plus 30 plus 360x equals 10x times x plus 30. I'm just combining this x and this 10 to become 10x. Okay, to solve an equation, we have to expand. So I'm going to have to expand this thing out. This will become 360x plus, oh boy, I need a calculator. 360 times 30, so 10,800 plus another 360x equals 10x squared plus 300x. After I expanded, I recognize, hey, this is a quadratic, so I need to move everything over to the right. When I do that, I'm going to have 10x squared. Then I have 300x minus 360x minus another 360x. That gives me a negative 420x. And then I subtracted that 1080 or 10,800 to the other side. Giving me that quadratic to try to solve. You have different methods of solving that, right? You can do box method, quad formula, or factor. I'm going to factor it. The first thing I'm going to do is take a GCF out, right? So that GCF of a 10 comes out, leaving me with x squared minus 42x minus 1080. And then I do a diamond. On the top, I'm looking for things that multiply to be 10,080. Add to be negative 42. Which would give me negative 60 and positive 18. So this thing factors to be x minus 60, x plus 18. Meaning that x equals 60, and x equals negative 18. Remember that x was our speed, right? So if you think all the way back to our original question, we started putting x as our speed right here. Here's our speed there. So this answer doesn't make any sense. I'm not going to have a speed of negative 18. So my answer, the question said, determine Mario's average speed on each leg of his journey. X represented his speed there. So his speed there equals 60 kilometers an hour. His speed back, if you remember from the question, was 30 kilometers faster. So it's 90 kilometers an hour. And that is our first word problem. Usually, people are kind of floored by it. They find these hard. There's a lot of information there. We're going to do a couple more so you can hopefully get a little handle on it. This one's talking about Jerome rowing a boat. So Jerome rows his boat 24 kilometers downstream and back to where he began. When the average speed of the current is 2 kilometers an hour, Jerome can complete the journey in 9 hours. What is Jerome's average speed in still water? Okay, so this is a motion problem, right? I know it's a motion problem because it told me that something was moving, right? 24 kilometers down and 24 kilometers back. It also gave me total time, and that's where things are going to start for me. It says Jerome can complete the journey in 9 hours. That means his time there, or time downstream, plus his time upstream, coming back, equals 9 hours. It's then our job to turn these times into formulas using time equals distance divided by speed. So when we talk about time down, let's change it into distance downstream divided by speed downstream. The distance that he drove downstream was 24 kilometers. Therefore, it would be 24 divided by his speed downstream. We don't know his speed downstream. That's what it's asking us to find, right? What is Jerome's average rowing speed? So we don't know, so we put X as the speed. But we do know something. We know in this question, it said the average speed of the current is 2 kilometers an hour. That matters. The reason that matters is if you... most people haven't rowed a boat in a river. So I like to use a running analogy. You know when you're a little kid and like you go for a run outside at recess or gym class or something, but you run outside. And when you're running with a really strong wind behind you, it feels like you're running so fast, right? You're just like flying out there. That's because the wind is actually pushing you. It's giving you a little boost. But when you turn around and you run into the wind, you feel like you're the slowest runner in the world, like you're Mr. Kennedy running on a basketball court, right? It's just like dragging you down. That's because the wind is blowing in your face and it is actually slowing you down. Well, current in the water does the same thing. When you swim down current or you row a boat down current, you're actually getting a boost by however strong the current is. So in this case, when they said the average current is 2 kilometers an hour, that means my speed downstream is plus 2 kilometers an hour. I'm getting a boost. Like I'm rowing, and that's one speed, and then I'm getting a 2 kilometer an hour boost. Then I add my time upstream. My time upstream, well, the distance is the same, so it's 24, divided by the speed upstream. We still don't know speed, so it's X. But this time, instead of plus 2, because I'm coming back upstream, it's actually minus 2. And that equals 9. Building the equation is almost always the hardest part. Once you have that, you can solve it by getting common denominators. Remember that 9 needs to have a denominator too. So I put brackets around these things to remind myself they're packages. That means this one needs an x minus 2, top and bottom. This one needs an x plus 2, top and bottom. And this one needs both. Once you have a common denominator, the denominators can go away. And you have 24 times x minus 2 plus 24 times x plus 2 equals 9 times x minus 2 x plus 2. Like that. Anytime you want to solve, right, because you've got rid of your denominators, now you want to solve, you have to expand. So we're going to multiply that 24 in to become 24x minus 48. This will be plus another 24x plus 48. Over here, the 9 stays out, and then you multiply these two things together. When you multiply those two things together, you get x squared minus 4. On the left-hand side, I can collect like terms, so I have 48 x's, 24x and 24x, and the 48s actually cancel out. Equals, on the right-hand side, the 9 comes in, I have 9x squared minus 36. Like that. Now that I've fully expanded, I can check out what type of equation I have. It's a quadratic. I solve quadratics by making them equal to 0 and then factoring if possible. So I move that 48x over. That gives me 9x squared minus 48x minus 36. To factor that, I'm going to take out a greatest common factor. Everything can divide by 3. So I have 3x squared minus 16x minus 12. I need to do diamond method on that. When I do diamond, I'm looking for something that multiplies to be negative 36 and adds to be negative 16. That'd be negative 18 and positive 2. So this becomes 3x minus 18, 3x plus 2. One of these has to divide by 3, giving me 0 equals 3x minus 6, 3x plus 2. I get my two solutions. The one solution is x equals 6. The other solution is x equals negative 2 over 3. We know that x represented the speed of me rowing the boat, right? From the very original question, that's what this x represented. It was my speed. So the negative 3 over 2, or the negative 2 over 3, does not make sense. I would not row at a negative speed. So the speed in which I'm rowing is 6 kilometers an hour. Now, that's what it asked for. It asked for the speed of him rowing. If it asked for the speed of him going downstream, it would be 6 plus 2. If it was the speed of me going upstream, it would be 6 minus 2. But 6 represents how fast he was actually rowing. Fantastic. There's one more here. I want you to pause the video and just try to set it up. Don't try to solve it. Just try to set it up. And then unpause the video and you'll see the actual setup. All right. Hopefully you did that. To set this up is a little bit trickier. So it says, a boat travels at an average speed of 15 kilometers an hour in still water. The boat travels 12 kilometers downstream in the same time. That's how we're going to build our equation. In the same time means that time downstream should equal my time upstream. And then I can build my equation with all of my information about distances and speeds. But I have to start with time. Then let's try to turn time into distance divided by velocity. Distance divided by speed. So when we do time down would be distance downstream 12 kilometers downstream, divided by the speed downstream. They told me that the speed, a boat travels at an average speed of 15 kilometers an hour in still water. So they're telling me that the boat is going 15 kilometers an hour. But because it's going downstream, I have to add X because I'm getting that boost from the current. And I don't know what that boost is. In fact, the question says, determine the speed of the current. That should equal my time upstream. Well, my time upstream would be distance upstream, which is now travels 8 kilometers upstream, divided by my speed upstream, which is still 15, but this time it's minus X, subtracting that boost. Hopefully you got the setup. I'm going to answer this really quickly, but that would have been the setup. To solve this thing, you need a common denominator. Remember, these are in brackets. So I'm going to have to multiply this one by 15 minus x, this one by 15 plus x. What I do to the bottoms, I do to the tops. So that means I now have a common denominator, which can go away. That gives me 12 times 15 minus x equals 8 times 15 plus x. You expand that. 12 times 15 is 180 minus 12x equals 8 times 15, which is 120, plus 8x. That's a linear equation, so I need to get all the x's to one side and constants to the other. I'm going to add 12x to both sides. I'm going to subtract 120 from both sides. That gives me 60 equals 20x. Divide by 3. And I get that 3 equals x. The speed of the current is 3 kilometers an hour. The setup's the hard part. I know you can solve those, right? But the setup is where you really need to focus. All right, those are our motion problems. The next type of problem we're going to do is a work problem. The work problems can be anything. So this one is mowing the lawn. I've seen work problems that are like serving dinner. I've seen them that are vacuuming. I've seen them that are cleaning houses. I've seen it that are all kinds of things. Just give me a second. I think I see somebody robbing somebody outside my house. That's not. I've said some weird things in class before. I don't think I've ever stopped class because I'm watching somebody rob somebody. It's like 10 o'clock at night right now. I'm filming this video for your class, and there's some dude who was in my back alley, and I can see from a kitchen. He's just creeping through people's backyards. So I went and turned on the light and scare him away. What a night! Look at us. We're doing math and saving lives. All right. That's weird. So. Anyways, these work problems, these work problems can be pretty much anything as long as there's a job being completed. It could be, like I said, shoveling driveways, painting houses. It could be robbing people. As long as there's a job happening, you're doing a rate of work problem. So this one is Kyra mowing the lawn with Mark. It says Kyra mows the lawn in 40 minutes. When Mark and Kyra work together, they can mow the lawn in 24 minutes. How long would it take Mark to mow the lawn on his own? Okay, I'm going to draw a little bit of a picture to represent what's going on here. So we have a lawn, right? I'm going to even do the green lawn because I really care about you guys learning. Look at this, the green lawn. Okay, if we picture two people working on this together, we got Kyra starting on one end, and she's going to start mowing the lawn. So she's going to be like, mowing the lawn. Oh, geez. I want to go back to this. Mowing the lawn. And she's going back and forth and back and forth and back and forth. And she's mowing this lawn. And Mark on the other side, he's doing the same thing. He's mowing the lawn, back and forth, back and forth, back and forth. And eventually, they keep mowing the lawn. Right, they're going along, and they run into each other, which means that they're done their job. They're done mowing the lawn. And the reason I like to do a picture for this is because if we look at it, we will notice that Kyra has done a fraction of the job. She hasn't done the complete lawn, right? She did a fraction of it. And if we look at the other side, we'll see that Mark has done a fraction of the job. But together, they have one job done. Let me do this. And this will go for everything, whether it's making burritos, breaking into my neighbor's house, whatever. Two people are doing a job. One person does a fraction of it. The other person does a fraction of it. And together they have one completed job. Okay, that is how we're going to build our equations. We have to have a fraction, which will be Kyra's fraction, plus another fraction, which is Mark's fraction, and total, it will equal one job done. And all of our work problems will look like this. One person did a fraction of the job, another person did a fraction of the job, and together it was one job completed. These fractions have two things. They have a top and a bottom. The top is the time it takes to do the job together. The bottom is the individual time. So I like to go time together, TT, individual time, IT. So let's see if this works. Time together. In this question, it told me they can mow the lawn in 24 minutes together. Together, they can mow the lawn in 24 minutes. So that means 24 is my time together. So I have 24 plus 24 divided by individual time. Kyra's individual time is 40 minutes. Mark's individual time is unknown. How long would it take Mark to mow the lawn on his own? That's X. And together, it equals one job done. Again, the setup is the hardest part. If you have it set up, everything else should go smoothly. To solve this, you need a common denominator. Remember, this 1 is 1 divided by 1. So that means I need to multiply this one by 40 and this one by 40. I need to multiply this one by X and this one by X. So I have 24X plus 24 times 40 equals 40X. The denominators are gone. That's a linear equation. To solve it, I subtract 24 to the other side. That gives me 960 equals 16X. And I divide both sides by 16. And that gives me 60 equals X. X was how long it takes Mark to mow the lawn. That was the question. That means it takes Mark an hour or 60 minutes to mow the lawn by himself. Slower than Kyra. Cool. That's a work problem. This is another work problem. This one's painting garage doors. I want you to try to set it up. So try to set it up and then unpause the video and see how the setup should look. All right, to set this up, you had to realize that you had Marissa painting part of the garage, Roger painting part of the garage, and they both will do a fraction of the work. If you add their fractions of the work together, you get one job completed. These fractions have their times together on the top and then individual time, so Marissa's time and Roger's time on the bottom. If we read it, we can get the information. Marissa can paint it in 3 hours. Awesome. That's Marissa's time. So I have something divided by 3. Keep reading. When Marissa and Roger work together, they paint it in 1 hour. That is my time together. 1 hour. How long would it take Roger to paint it on his own? That is Roger's time, which is X. And you get that beautiful equation. Hopefully you set it up properly. So it's 1 over 3 plus 1 over X equals 1. To solve this, you need to get a common denominator. Common denominator means this needs to be multiplied by X, this by 3, this by 3X. The denominators all go away. And I have X plus 3 equals 3X. I move my X over. I have 3 equals 2X. I divide by 2, and I get 1.5 equals X. That means it takes Roger 1.5 hours to paint the garage door on his own. Again, the setup's the hard part. The solving usually isn't that bad, especially for work problems, but the setup is the hard part. All right, last type of problem we have, and it's the last example we're going to do, is a proportion problem. So this is when they're mixing something. So whenever you're mixing something. Okay, and it could be anything. This is antifreeze in water. Sometimes it's oil in water. Sometimes it's like sugar and, I don't know, salt. That's a weird mixture. I don't know. It could be anything. Anything that's mixing is going to be one of these proportion problems. And what people do is that they're going to get like an amount given to them. So it says antifreeze is added to water to make a solution that is used in automobiles. How much antifreeze must be added to 12 liters of water to make a solution that contains 40% antifreeze? And here's what everybody does. Everyone's like, oh, this is the easiest question ever. And they take the percentage, they change it to a decimal, 0.4, and they multiply it by 12 to find out what 40% of 12 is. They do that and they get 4.8, and everybody answers 4.8, and they're like, oh, that's the easiest question on the test. Oh. And I'm like, no, it's not 4.8, you crazies. What this just calculated is what 40% of 12 is, and that's not what you want. You want the mixture to be 40% antifreeze. So if you were to mix this 4.8 with the 12, you now have 16.8 liters of liquid. And 40% of 16.8 is 6.72. But you don't have 6.72, you mixed in 4.8. So you didn't mix in enough. You do not just take the percentage and times it by the amount. That will not give you enough. Instead, anytime you have a mixing problem, you need to make a formula. That formula is very scientific formula that I created myself. Okay, it goes like this. It goes, the crap you add to the mix divided by the total crap you get should equal your percentage. Very scientific. Very scientific. So that means no matter what the question is, however much crap you're adding goes on the top, and you divide it by the total amount of crap that you're going to get at the end. And that should equal your percentage. So for this question, it says antifreeze is added to water. Antifreeze is added to water. So the crap I'm adding is antifreeze to make a solution used for automobiles. How much antifreeze must be added? Okay, that's the crap I'm adding right here. They said how much. I don't know how much. So I have X divided by, let's go back and read the question. How much antifreeze must be added to 12 liters of water to make a solution that contains 40% antifreeze? Okay, the total amount of crap I get is not 12. 12 is how many liters of water I have. But then I added my antifreeze. So the total crap is the 12 liters of water plus the X amount of antifreeze that I added. And that should equal your percentage, which is 40% antifreeze, which is 0.4. We should change our percentage to decimals, right? And that is my formula. The amount of crap you got to add divided by the total amount of crap you got equals 40%. To solve this, you got to remember that this is divided by 1. You need a common denominator. This 12 plus X needs to be multiplied to the other side. When you do that, cancel out the denominators, and you get X equals 0.4 times 12 plus X. You multiply the 0.4 in, and that gives you, I'm just going to slide over here, it gives you X equals 4.8 plus 0.4X. We subtract our 0.4X to the other side. That gives me 0.6X's. Right? So that was 1X minus 0.4X. So that'd be 1 minus 0.4 equals 4.8. And then I divide 0.6. And that gives you the amount that you need to add, which is 8 liters of antifreeze. I need to add 8 liters of antifreeze. There you go. That's math. Crap you add, crap you got. The actual science, oh yeah, we take science. That's not the term. My science teacher says you don't use the phrase crap you add. Yeah, whatever. So the actual scientific formula, if you want to be about that life, is solute divided by solution equals your percentage, which I think they have a name for that too. Concentration. But who's got time for that? Solute and solution. Like, come on, man. I'm out here breaking up crimes like a superhero and trying to teach math, and you want me to use science words like solute and solution? Like, come on now. Crap you add, crap you got. Equals percentage. That's the best I got for you people. Anyways, I hope you're all ready for a good long weekend. Rest up, honestly. Like, take some time to yourself. Rest up. Text some people you know. Send some Snapchats, Instagram something. Do something that makes you happy. Go outside, go for a walk. Take care of yourselves. You guys deserve a long weekend. This has been a tough little goal for us. So take care of yourselves. Mix in some math if you're feeling good. If you're not feeling good, then math can wait. We'll worry about it next week. Enjoy the rest of your day. I'm not going to finish off these questions because we've done enough. This is a long enough video. There's lots of practice in your practice booklet. Take care of yourselves. See you later.